The next speaker will be Vittorio Iacovella of the University of Trento, and he will talk about a project that tries to develop a virtual space to share outputs of the research. Thank you, and the floor is yours.
Thanks for this introduction. Can they hear me? Okay. It's Vittorio Iacovella from Center for Mind Brain Sciences at the University of Trento. This is a research center in cognitive neuroscience. So people in my facility, they work with the brain. I'm a technician there, and I'm in charge of this experience called Think Open, which is an initiative trying to introduce open science into a cognitive neuroscience research environment. Open science, something that relates to what happened in the last decade, where there was what in science it was called replication crisis, so sort of crisis of credibility of the results that came out in especially psychological science. And a part of the sensational titles, something like "Is Science Broken?" We cannot really rely on what is published anymore. This actually triggered and the consolidation of the open science movement. If you want to know more, you can read this amazing book. It's an open book. It's called Open in Science. If you want, there are many topics covered in this book, but one of the most interesting part of the story they tell is a sort of taxonomy of open science, because you have here on the right this kind of area regarding citizen science, so something like democracy of knowledge and so on and so forth. And on the left, there is a more pragmatic school related to accessibility to infrastructure, open data, open code, open analysis. And that's the focus of today's talk and my everyday job at CIMEC. When I have to present something to an audience that I don't know, and I do not have time to do the classic raise your hand routine, I open a dictionary and try to see how I can communicate the core of open science concepts. I choose to show you the verb share because it pretty much says everything. So it partake of, use, experience, occupy, you enjoy with others, and that's one of the pillars of open science. The interesting part of reading a dictionary, which is an activity that I really enjoy, by the way, is the fact that it's not only the definition, but also all this kind of, let's call it like this, decorators or whatever, other parts of this definition, because on the dictionary it's written down that sharing is a transitive verb. This means that to complete, let's say, the understanding of the meaning of share, you have to specify something which is directly related to the verb itself. And so we can share or distribute pieces of fair information fairly, persistently, and to everyone, but to some sense we can share actual pieces of information, objects, and that's what we can call object-oriented framing of open science. But if we kind of take a step aside and try to think about something which is more broad and broadly applicable, we can say that we can disseminate something which is different from the object themselves, and disseminate practices of processing and transforming information. So this process-oriented framing of open science is the one that drives the experience of Think Open at CIMEC. If you want to know more, you can read this amazing essay by Professor Sabina Leonelli, Philosophy of Open Science. This is a journey into what's behind the conceptual basis of open science. And Think Open at CIMEC, it's a conceptual space per se. It's a virtual space where researchers can share practices and outputs from every step of the research process. And what we notice is that with this process-oriented framing of open science, so not only sharing data or manuscripts or whatever, but ways to build data and manuscripts. Early career researchers, for example, they can build an open science portfolio integrating open practices within their everyday routine. Today, I would report two practical examples. The first one is related to data verification. It's basically the operation of transforming what could be, for example, a spreadsheet, which is readable by humans, or I would say just a restricted set of humans, your lab, but if you have such a representation of your data, it's very unlikely that you yourself in 6 months are not able to read it anymore. So as one part of open science portfolio and a practice to be shared, we disseminate the verification of the data set, preparing and transforming collection of files into a properly arranged data set according to specific and certified schemas. Here I mention brain imaging data structure because we work in the domain of research on the brain, but there are many other schemas and many other applications that you can look for yourself related to your working field. Another part of the story, another practical implementation of this process-oriented framing of open science and process-based building of communities is to switch from this, I don't know, familiar, I hope not, but it's very likely that, for example, an early career researcher or first-year PhD student, he or she, they're used to work in this way, so labeling files in a messy way, adding names to, adding nonsense words to file naming. What we try to disseminate in order to avoid this mess is to switch from a command-based data analysis, description of data analysis pipeline to a operation-based data analysis pipeline. If you want to know more about this, you can read this amazing paper by Van Vliet, 7 quick tips for analysis script in neuroimaging. This is not, let's say, it says neuroimaging, but it's widely applicable in whatever domain of experimental scientific research. And we disseminate the adoption of a version control system that could track all the changes in developing scripts. Early career researchers, they approached novel practices and original ways of doing their things. That's something that I want to stress. Myself as technician and other people involved in Think Open, we're not like the man on the mountains sharing in a top-down way how to do things. We sit together with people and ask what you're doing, what's your everyday research routine, and try to find paths of inclusion of open science practices into their everyday job. We also introduce recurring bottom-up informal initiatives to keep interest ongoing and establish new links. And what come out is that this kind of Moodle app and practice sharing, it kind of goes viral throughout generation of scientists because current, for example, early career researcher that benefit with the adoption, from the adoption of open science practices, they would pass this kind of conceptually considering their everyday working routine to future research generation. And this is what creates practice-based community, working together, dealing with something that proved relevant for my everyday job. And that's it. Here I report a few examples of open communities built on practices. First one is of course thinkopen at CIMEC. If you want to know more, just drop a line to this email, thinkopen.cimek@unidn.it. I was also the founder, together with the other 5 people, of the Italian Reproducibility Network. It's a practice-based community related to disseminating practices of reproducibility on the Italian scientific community. There is our 4th in-person Congress in Milan next February. If you want to know more, just take a look at the website. I'm also part of the Comunità Italiana Data Stewards. It's a local community dealing with extraction, transformation, loading, management, and data analysis in scientific domain. If you want to know more, you can drop a line to this mailing list saying vorrei iscrivermi. And these are just 3 examples of building communities based on practices. And if you want to replicate this in your field or in your domain, just drop me a line, we can discuss about this, and thanks for your attention.
So, thank you for the presentation. We have still a few minutes time for a question. Is there anyone that wants to pose a question? Otherwise, I have curiosity about the sometimes it's difficult to convince researchers to share their data or the data behind their research. Did you experience as well these cultural difficulties? And if yes, do you have also something or a suggestion about how can be overtaken this difficulty?
Thanks for the question. Well, for early career researchers, I think this was simply, I didn't really experience this, mainly because, so if you want to earn a living in this field, for example, international labs throughout Europe or US, you cannot really, you have to deal with, for example, version control, extraction, transformation, and loading of the data. And it's this way of thinking at the data that, let's say, increase somehow your value on the marketplace. With respect to, let's say, older generation of researchers, I would say that the fact that before sharing, you have to prepare your data for sharing. And transforming your data using standard grammar, I think it was something that opened up new interesting connection, because it created a common base for people in one researcher field, but also slightly different fields that, for example, until that point, they could not even have, let's say, a language to discuss. So, yeah, there was somehow this kind of very first, how can I say it, diffidenza. I cannot really get the English word, but right now. But I think that the benefits, they are really way over the learning curve and the fear of getting scooped and so on and so forth. So I think in experimental psychology, especially, I think the people that were kind of enthusiasts in some sense to adopt several practices.
Thank you.